So let's say a business recently did a study of its customers. A random sample of 60 customer accounts was pulled from the computer records and two variables were observed. The variable Y is the total dollar volume of business this year, and X is the number of miles the customer is from corporate headquarters. The statistics shown below were computed. So in this problem, you're not given a data set, you're just given information to work with. So this saves us a little bit of time about running regressions. In the first part here, you're going to be asked to interpret the regression slope coefficient. So it's saying, what is our B sub 1 telling us? And again, as a reminder, I've got the full model right here, right? Y equals B sub 1, B sub 0 plus B sub 1 times X. But and then here's the data we're given with. We've got some information here. Let's focus on our B sub 1 though. So here you can see the structure, and then go ahead and take a look at the scenario from our story. For each additional mile a customer is from corporate headquarters, remember X is the number of miles. So this X right here, for every mile we add, whether it's 10 miles, 11, 12, 13, every mile we go up by, the average total dollar volume of business, that's the Y, right? The total dollar volume of business is going to do what? So looking at this and knowing how the structure looks like, what's going to happen to our sales numbers, our volume of business? Is it going to go up or down? For every mile I add, it's going to go down. It's going to decrease. How do you know? Yep, that negative sign is our clue, because the original structure is the positive. So if we flipped it and changed it to a negative, that's going to tell us it's a decrease. So as our miles go up, as the farther our customers get away from us, our sales go down, or decreases, by how much? What's our change? So remember, X is the miles I'm putting in. So what's next to it? How much money am I going to lose for every mile I'm farther away? That's it. It's just the 1041. So when we're focusing on interpreting the slope, all you got to do is look for the number that's right next to the X, because the X is some number, the independent variable we're plugging in. Let's say it's 10 miles away, 15 miles, 20 miles, 25 miles. As those miles go up and up and up, we're going to interpret the change. And in this case, it goes down. We lose $10.41. So that's how we'll interpret our slope. Let's go ahead and move into the hypothesis test then, right? So we're going to use the significance level of 0.05. Let's test to determine whether it is true that the farther a customer is from headquarters, the smaller the total dollar volume of business. So based on this statement, are we doing an upper, lower, or two-tailed test? Lower, and the clue in this case is the word smaller, because that's what we want to know. Like, are we losing money the farther someone gets away? So we'll go ahead and write our null and alternative hypothesis so that the alternative has that less than symbol. And you notice that it points to the left, it points to the lower tail. So that's always how I visualize the direction I'm going to go in to make sure everything's consistent. The story tells me which way to go, and then I just make sure everything from the signs and my curve and the side that I'm going to focus on reflects that. Our degrees of freedom is the 60 customers minus 2, right? So that'll be our 58. And so what I notice sometimes is when we start to work with different problems, we start to mix up numbers. So you just want to be careful when you're looking at the homework problems that you find that sample size, find that N, and don't forget it, right? Just use that one for that number. So there's our 58. And we're going to go ahead and find the critical t-value. We have to find that, where does our rejection region begin? Where's that cutoff point? And we can go ahead and use Excel and use this formula, equals t dot inv parentheses the alpha and the degrees of freedom. So let me go ahead and pull up. Again, so if you're looking at the whole sheet, right, Since we're working with t's, you can see it in the story. We're going to be using this this right side. Don't know my sides. The right side of my worksheet. So then I'm going to go ahead and just zoom in again. Let me go ahead and clear out these from the last problem so we're not confused by it. And in this scenario, we were doing a lower tail test. I'm glad when you guys type in the chat because then that helps remind me. So we're going to use this formula right here. Just color it blue so we're working with different colors. So go ahead and type in equals t dot inv parentheses. The alpha was 0.05. That's just the level of significance. And our degrees of freedom, you can still see it's right here. It's that 58. Close parentheses, give it a shot. What do you get when you type that in? Negative 1.67 and some change. Fantastic. So there's my negative 1.6716. Again, just depends on what the homework asks for. 2 decimals, 3 decimals, or 4. Make sure to enter that in. If you just missed the rounding, but you got the right number, again, don't redo the whole problem. Just send me and ask my instructor, and I'll just manually grade it. So just be aware of that. But you do get 3 tries for every little answer you enter in. So hopefully you still have a try left to just fix that rounding. And then here's our test statistic formula. So let's make sure we put in all the right numbers in the right place. So our lowercase b sub 1. So this is our slope according to the sample. What is our b sub 1? And if you forget, here's my structure up here. And then here's the information from the problem. So what's my b sub 1? What's my slope? Good. But just remember, it's going to be negative 10.41. So we can't leave out that negative sign because that gives us some direction. Our big B sub 1, that's going to be the 0. So sometimes people forget, like, where does this number come from? It comes from the hypothesis test. So remember, because we're testing against the hypothesis. So that's just going to be 0. And then what's our standard error? What's our SB1? It's given to us in the homework problem. Yep, it's the 3.98. So just look for SB1. I know we're learning a lot of new concepts and a lot of terms, but sometimes the best thing is just look for the visual, right? And so if you've got your chapter 14 worksheet, there's a reminder on like the symbols and the letters. So you're just going to keep an eye out for that, and we'll go ahead, and those are the numbers we're working with. So go ahead and plug this into a calculator, into Excel. It's pretty straightforward math. You know, when we minus 0, nothing happens. So you can just, even ignore the minus 0 and just take these 2 numbers and divide it. Let me know what our test statistic is. What's negative 10.41 divided by 3.94? Negative 2.61 and some change. Again, just depends on the rounding. All right, so again, I'm going to do a visual. So we're still working with our normal distribution curve, but it is a lower tail test this time. So we're going to work on this side. I'm not drawing to scale. I'm just trying to make it big, right? That's my critical value, and that's going to be the negative 1.6716 that we found in Excel using the t.inv formula. The test statistic that we found, our t-stat for abbreviation, is negative 2.6156. Okay, so where does our t-stat fall in relation to the critical value? Which side? Where does it go? And if it's helpful, in the middle just is our 0. It's our beginning point. Yep, it's to the left. So it falls right around here. So are we going to reject the null or not reject the null? We will go ahead and reject. Remember, anytime we're in the rejection region, if we fell into that little tail, we were so lucky with our sample data that we're gonna reject the null. It is special enough to change our minds about something we're assuming about the world. So we'll go ahead and say, because our test statistic of negative 2.6156 is less than the critical value of negative 1.6716, we will reject the null. What kind of linear relationship is it? Is it going to be positive or negative? Again, if I imagine crossing out the null hypothesis, because we rejected it, right? We rejected this line right here. What's left is the alternative. What kind of relationship are we working with? Yep, it's negative. Thank you. I realized that. In other words, we can say, yep, the total dollar volume of business decreases, negative, as the distance a customer is from corporate headquarters increases. So once you've interpreted the hypothesis test, we have to then interpret it from our story. So what does it mean for the business? And so that's why it's helpful to describe it this way. And imagine if I cross out the null, then just interpret the alternative or what's left.